Okay, in this particular question, okay, we are learning about a few things. Okay, one of the few things that we learn about is the magnetic materials. Okay, so why do we learn about magnetic materials? Because magnets can be used for, how to say, uh, to do certain things for us. Okay, so for the first question, okay, which materials are magnetic? We have learned four materials that are magnetic. Okay, so what are the four materials? Okay, the first one, let me change color. Maybe I use blue. Okay, so that everyone can see. First one will be iron. Okay, next one will be cobalt. Okay, nickel and steel. Okay, so these iron, cobalt, nickel, and steel, they are very important. Okay, you should be able to remember all of them. Also at the same time, please remember that not all magnetic materials, okay, not all magnetic materials are, sorry, not all metals, okay, are magnetic materials. Okay, so not all. Okay, so very important concept. Not all metals are magnetic. Okay, so there are only four so far that we have learned. Okay, so some of your answers are not very good. Please do your corrections accordingly. Okay, next. Okay, next we have this question where it involves a lot of information. Okay, so I would like you all to take a look at this question again. Okay, when a mixture of white powder and a grey solid are mixed, the final mixture can be separated by a magnet. Oh wait, hang on, Nashmi is asking a question. Okay, where is Nashmi? Okay, Nashmi, what's your question? Metal cannot. You have to mention. You mean for question one, is it? You if you just write metal is not sufficient. It will not be correct. Okay, so you need to identify which are the type of metals. Okay. Yep. Okay. Thank you. Okay. So let's continue. Okay. The for question two, we talk about white powder and a gray solid. They are mixed together, and the final mixture can be separated by a metal. Okay. So you see that these two are mixed together. Okay. These two things are mixed together, and they actually say that it can be separated. So when you say separated, that means this mixture, okay, that you have, you must be able to separate into the white powder, okay, and the gray solid. Okay, so it must be literally separated into these two. Otherwise, it's not called separation. Okay, so if you look at all the things very carefully, if you look at the answer for A, if both of them, the white powder and gray solid are magnetic, then they won't be able to separate. Okay, the B answer, if the white powder and gray solid are soluble in water, this is actually nothing related to magnet. So it is definitely wrong. So A and B are definitely wrong already. Okay, now if you look at the answer for C, okay, the white powder is a non-magnetic material while the gray solid is magnetic. Okay, so this is our answer. Why? Because if this is true, then the mixture can be separated into the white powder and gray solid. Why? Because the gray solid is magnetic and it will be able to be removed by the magnet. Okay, so please take note of all this. Yeah. Okay, part D, sorry, answer D, the white powder is soluble in water while the gray solid is insoluble in water. Okay, this question has nothing to do with solubility in water. That's why we don't consider that as an answer. Okay. Okay, for those who cannot catch on, don't worry, I'll post up this particular video so that you can actually take a look at it later on. Okay. Question 3, which of the following can be separated by magnetic attraction. Same idea, I want to separate it by magnetic attraction. So same idea, I have this particular mixture which I need to separate into one thing, okay, that is magnetic, the other thing that is non-magnetic. Okay, so answer to this question is actually A. Okay, because iron is magnetic, okay, sand is non-magnetic. Okay, so when you have a mixture, one of them is magnetic, one of them is non-magnetic, then you can separate them. Otherwise, it's not possible. Okay, so many of you actually gave the answer as iron and steel. Both iron and steel are magnetic materials. Okay, so if both of them are magnetic materials, they cannot be separated. Okay, so imagine this, I take a magnet and I bring it close to this iron and steel mixture. Both the iron and steel mixture will be, both the iron and steel will be attracted to the magnet, so there's no difference. Okay, question 4, which of the following cannot be separated by magnetic attraction? Okay, same idea again. Okay, but this time it's a bit more difficult because there is alloys. Okay, some of the alloys has magnetic materials in them. Okay, so answer for this is actually A. Okay, because I want cannot. Okay, so if you look at the answers for B, C, and D, okay, you notice that certain things have these magnetic materials, certain things doesn't have. Okay, so cobalt is actually a magnetic material like what we have learned. Okay, but copper is not, so it can be separated. Okay, nickel is a magnetic material, zinc is not. Okay, so it can be separated. Okay, nickel is a magnetic material in B. Brass is actually doesn't have any these nickel or cobalt inside, so that's why it is actually able to be separated as well. So A is the answer because both cobalt and iron are magnetic, so they cannot be separated by magnetic attraction. Okay. Question 5. Which of the following is an example of using a magnet to separate a mixture? Okay, so answer is actually B. Okay, so this one quite straightforward because I want to separate a mixture. Okay, so A, C, and D has no form of separation. Okay, no form of separation. Okay, so that's why we don't consider that as the answer. A, C, and D are not the answer. Okay, so far, anyone has any questions? I give you all 30 seconds to respond. If you have no questions, sorry, if you have question, please do the electronic raising of hand. Okay, if not, I shall continue. Okay, 30 seconds. Huh? Okay, let's continue then. Okay, for question 6, I know this diagram is a bit lousy, okay, but actually the picture that they want is actually this particular picture. Okay, so what is this particular thing? This is actually a beaker. Okay, this is actually a beaker. Okay, so many of you didn't get it right probably because of the misleading line in the center there. So I'm very sorry for that. Okay, so let's continue. Okay, B is actually a filter funnel. You need the word filter. Many of you did not use the word filter funnel. Okay, you need this filter funnel. Okay, if you don't have the word filter, it is not correct. Okay, it is not correct. Okay, C is actually a filter. Okay, you can put as paper filter. Okay, something along that line will do as well. Okay, but in our case, we are just talking about filter because I'm using a filter to do filtration. Okay, D is a conical flask. Okay, without the conical word conical is not correct. Okay, it should be conical flask. Okay, because of its shape. So please remember all the these shapes as well. Okay. Okay, next one, state the generic names of X and Y. Now, if there's anything that's left over inside the filter, okay, this is called a residue. Please remember this name, residue. Okay, Y is actually the filtrate. Okay, so for filtration, okay, you can actually obtain residue and filtrate. Okay, so I will jot down some notes at the side here. Okay, for filtration. Okay, filtration, okay, you actually obtain two things. Okay, first one is the residue. Okay, is a solid. Okay, and the filtrate, okay, is a form of liquid. Okay, so you need to take note of it. Yeah. Okay, so filtration is there to separate these suspensions. Okay, used to separate suspensions. Okay, for the next one, part C, explain why X and Y are able to separate as shown in terms of their particle size. Okay, many of you have the general idea that you are able to tell me that X, because of the uh, particle size, is gets stuck with the pores and so on. But many of you, although you have the idea, you did not specifically mention that X, because of the particle size, it cannot go through the pore. You have to mention something related back to the question. Okay, so when I finish marking the worksheet 4.1 to 4.4 today, I'll return you all take a look at what I wrote inside there. Okay, so you have to say that X has particle sizes larger than the pores. Okay, so relate it back to the question. Okay, that hence it cannot flow through. Okay, hence it cannot go through the hence it cannot go through the pores of the filter. Okay, sorry, Mr. Lim is writing on the computer screen, so it tends to be a bit bigger as well. Okay, okay, so this is one of the two main points. Okay, the other being that Y has to be this Y particle size for Y is actually smaller, so it can go through. Okay, particle size for Y is smaller, so it can flow through. Okay, so please take note of that. Yeah. Okay, anyone has any questions for part C? Okay, no questions, let's carry on. Okay, students, please take note that of this word application. Okay, I think some of you did not understand what it means. Application actually means the users. Okay, application actually means users. Okay, so in part D, okay, in part D, state one application of filtration. Basically, they are asking you what is the use of filtration. Okay, so there are quite a number of users. You just need to name one of them. So, for example, one example that you can actually say is to filter. Okay, filter soil out from muddy water. Okay, this can be one of the answer. Okay, so it's almost everything. You can even say that the this let's say this macaroni, okay, is filtered off from the water to obtain your macaroni, okay, after while cooking. Okay. Okay, I shall move on to the next question. Okay, I'm trying to keep to the 20-minute limit here. Okay, what is the separation technique shown in the process above? So in this case, you have mixture of solid and liquid, and is this soluble? Okay, if it's not soluble, then you use this separation method. So in this particular case, they are actually referring to filtration. Okay, this is separation technique because it is not soluble. One of the things is not soluble in the mixture. Okay, so the solid, if it's not soluble, I can actually retrieve the solid back using filtration. Okay, that's the idea. Okay, part B. 3 mixtures that are commonly found at home are listed below. Okay, you have these 3, tea brewed with fresh Chinese tea leaf, homemade barley drink with barley seeds, and fruit pulps in the fruit juice. Okay, which mixtures, okay, can be separated by the separation technique? Okay, so which mixture? Yeah, so if you look back at the question, okay, I need to use filtration, okay, to remove the tea leaves from the tea. Otherwise, you'll be drinking the tea leaves with the tea. Okay, same thing for barley. You need to use the filtration to remove the barley seeds from the homemade barley drink. Okay, and the last one, fruit pulps. Okay, you need to use this filtration to remove the fruit pulps as well. Okay, from the fruit juice. Okay, so for those who don't know what this means, think of your fresh orange juice. Okay, when you first squeeze the fresh orange to obtain its juice, you actually get the fruit pulp as well. Okay, so in order to remove the pulp, okay, you use filtration to remove the pulp so that you just get the orange juice. Yeah, okay, so what is the answer for this one? 1, 2, and 3. Okay, all 3, yeah, all 3 of the above, 1, 2, and 3. Okay, next one. Which of the following explains why sugar cannot be obtained by evaporation? Okay, so this one was actually covered in the slide itself. The answer is this. Okay, C, it will decompose into water and carbon. So evaporation, one important thing to take note is that evaporation cannot be used on solids that is not stable with heat. Okay, so take note of this. Okay, jot this down please, students. Evaporation, okay, cannot be used, okay, on soluble solids that are not stable with heat. Okay, meaning they break down when heat is applied. Okay, so one such example is actually the sugar. Okay, there are others out there. We just leave it be for the time being. Okay, state one application of evaporation. You can say to obtain salt from seawater. Okay, so you can say that to obtain, my two writes very uglily, to obtain salt from seawater. Okay, so please take note of all these things as I go through. Yeah. Okay. Next one, question 10. Okay, question 10. What is the correct sequence of obtaining dry samples? You want dry samples, okay, for each component from a mixture of salt and sand. So now imagine this, you have salt and sand together. They have been mixed together. How do we actually separate them? Okay, so the first step is actually to add water and stir. Okay, objective of this is to dissolve the salt. Okay, objective of this is to dissolve the salt in water. Okay, so once you do that, you notice that the sand is insoluble. Okay, So step 2 is actually to remove the sand. Okay, to filter the sand. Okay, so to obtain sand as residue. Okay, the objective of filtering is to obtain sand as a residue because sand is insoluble. Okay, and last but not least, when we evaporate, we actually talk about we actually want the salt. Okay, so basically is to obtain a salt. Okay, to obtain salt. Yeah, so the correct sequence would be 1, 3, 2. Okay, so I've written down a lot of the explanation over here. Please take a look. Okay, and understand, okay, why do we actually go through this process. Okay, this sequence cannot be mixed up, because if you mix it up, then you actually miss out the whole idea altogether. Okay, oh, my word is not responding well. Okay, give it a while to respond again. I hope it works. Yes. Okay, let's continue. Okay, number 11. Okay, describe a suitable method for obtaining a pure dry sample. You want a pure dry sample of salt from a mixture of sand and salt. Okay, so it's actually what we have mentioned in the previous part. Okay, it's actually what we have mentioned in the previous part. Okay, so first one is actually to add water. Okay, to dissolve to the mixture. Okay, so that it dissolve the salt. Yeah. Okay, so the next step after you dissolve the salt, you need to filter. Okay, filter the mixture. Okay, why do we want to filter a mixture? Because we want to get the residue, which is the sand. Okay, the sand is the residue because sand is insoluble. Okay, sand is insoluble in water. Okay, and the filtrate is the, in this case, the filtrate is the salt solution. Okay, remember salt was dissolved. Yeah, so when salt was dissolved, the water, okay, the solution they actually get is actually salt solution. Okay, so salt solution is able to pass through the filtrate itself. Sorry, this filter paper itself. Okay, next one. So the last part here is a bit tricky. It actually comes from the PowerPoint slide. Okay, but you can actually use different phrasing later on if you are asked to write on your own. Okay, but for this particular one, we are looking for evaporates. Okay, evaporate the filtrate to dryness. Okay, evaporate the filtrate to dryness to get the salt itself. Okay, once we remove the water from the salt solution, we actually get the salt. Okay. Okay, now last question. Okay, describe how a mixture of sand, salt, and nickel can be separated. So once you look at this sort of question, this is actually a question that is very simple to answer if you understand the things. Huh? So what do I mean by understand the things? Okay, you need to look at the these sand, salt, and nickel and think about what we have learned earlier. Okay, so nickel, we know that nickel is a magnetic material. Okay, we know that nickel is a magnetic material. So when it's a magnetic material, it is able to be removed by a magnet. Okay, yeah, while salt and sand, okay, these two is like what we have mentioned before. So salt and sand is basically salt is insoluble in water. Okay, insoluble in water. Okay, while salt is soluble. Okay, so how are we going to proceed to remove these three things that is mixed together to become individual things? Okay, so step one. Okay, step one. okay, is that this use a magnet to remove the nickel. Okay, so you have to use a magnet first so that we can remove the nickel. Okay. Okay, your objective is always to try to get the dry one first, okay, the dry items, okay. If you don't get the dry items, it's a bit more difficult later on. So that's why I use a magnet first, okay. Step 2, okay, step 2, add water to remaining mixture, okay, to dissolve the salt. Okay, so after you do this, you able to get that the salt is actually this salt solution, okay, and sand suspension. Okay, so I'll use a different color to indicate for you what is left over, what is actually obtained from here. You get salt solution plus sand suspension. Okay, of course you need to stir. Okay, so please you need to stir, students. Okay, next, okay, number 3. Okay, my laptop is a bit slow now. Let me get this color change. Let it be done. Okay, number 3. Okay, so now you have this salt solution and sand suspension. Okay, now I'm going to remove the sand. Okay, so I am going to filter, okay, the mixture. Okay, why do we want to do that? Basically, once we do that, we'll actually obtain. Oh, sorry, I should have add in the word comma here. Okay, no comma there. Filter the mixture to obtain sand as residue. Okay, so now you have sand as a residue in this filtration method. Okay, can? Okay, and but okay, many of you actually stop here. Okay, there's actually a step number 4 because you have not obtained salt yet. Okay, you have not obtained salt yet. So number 4, okay, you need to evaporate the salt solution to dryness to obtain salt. Okay, so you have to dry out, okay, remove the water from the salt solution in order to get the salt back. Okay, so in this particular question, okay, you have actually applied 3 different things. Okay, so let me use 3 different colors to indicate. First one, okay, is actually the step 1 is actually using magnetic attraction. Okay, to remove something from the mixture. Okay, second one, okay, which is the filtration. Okay, this one everyone should be quite familiar with it already. So this method that we use here is actually called the filtration. Okay, and last one at the end there. Okay, last one, let's maybe use wait. Okay, last one that we use here is actually evaporation. Okay, so different methods is used to obtain different items, okay, through all these things. Okay, so after going through this particular questions, okay, whole list of questions. Are you all able to understand this better? Yeah? Okay, I've unmute everyone. Everyone can understand it better? Okay, so, okay, good. Okay, so what I need you all to do is this. Okay, go and look at your workbook. Okay, your workbook, the worksheet 4.1. Okay, workbook worksheet 4.1. I need you all to go and relook at the questions you have attempted. Okay, and check your answers. Okay, because all those will be actually due this Friday. Okay, so after knowing all this, I want you all to relook everything. I will mark and grade. Okay, I'll grade that last workbook questions there. Okay, so with this, let's end the meeting here. Okay, I hope you all have understood everything. Okay, then we shall continue this. Tomorrow we'll do this. Tomorrow what do we do? Tomorrow let's do. I will do a video recording on the next paper 4.2. Okay, I need you all to see it, and then from there we will look at it. Okay. Okay. Any questions, everyone? Okay. Rain, yes, you got a question? You can't hear me. Oh, okay. Okay, it's okay. I have recorded the whole process, okay, the whole thing, okay, on my laptop. Later I'll post a video link for all of us, the rest of them who didn't manage to get in, to see. Okay, so with this I'll end the whole session now. I'll see you all again on Friday, but tomorrow still read through or still go up to the SLS to get the task to do. Okay, everyone? Yep. Okay, so see you all again, okay, on Friday. Nashmi, you got a question? Nashmi, yes, what's your question? Sorry, the workbook is it? Workbook 4.1, yes. You must have your workbook with you. Okay, can? So I'll end the meeting for everyone. Thank you everyone for your participation. Okay, I'll see you again on Friday. See you. Okay, bye. Bye. I miss you all.